Good morning. My name is Michelangelo Rossi, and today I'm going to present my paper, Quality Disclosures and Disappointment, Evidence from the Academy Awards. Okay, let me start with a bit of context about quality disclosures, such as certifications, that are able to reduce informational asymmetries by changing buyers' expectations over the quality of the sellers who receive a certification. For example, a used car receiving a certificate from a mechanic is likely going to be sold with a higher price, and we may think a movie who receives an award to be high quality. Now, this is the standard adverse selection story, but what if buyer's utility depends on a reference point, and this point is related to their expectation, right? Expected quality. Well, in that case, the buyers will display disappointment since they expected high quality and maybe the realized quality did not match their expectation. So with this regard, quality disclosures may not be beneficial for the perceived utility or the satisfaction of users, even if they remove part of the uncertainty. Now, in this paper, I identified the disappointment effect due to quality disclosures by estimating the impact of nominations to the Academy Awards on movie ratings. Okay, so that should describe that utility of moviegoers. So now I use this specific framework because first, movie quality is fixed over time. We don't have ongoing effort. Moreover, prices to go to a movie theater are quite constant and they do not tend to change depending on the awards. Therefore, here the main issue will regard isolating disappointment from the selection effect in the profile of moviegoers. Now, for the sake of time, I will skip the literature review, but I would like to emphasize that, up to my knowledge, this paper is the first one, right, to use a shock-based identification strategy to measure disappointment related to quality disclosure. Okay, now, what I'm going to present here. So I will start presenting the dataset I use. Then I will pass to the theoretical framework to help us informing, let's say, the identification strategy. And then with two different types of diff and diff, I will show how movie ratings behaves before and after shocking expectations. And I will try to isolate disappointment from selection. So the dataset. So the dataset comes from MovieLens, an online movie recommender system active since 1995. And in this website, users rate movies and get personalized recommendations. Okay, so I use the MovieLens 20 million datasets provided by the University of Minnesota, and it contains more than 20 million ratings for more than 27,000 movies and a lot of users. But specifically here, we are only looking at users who rated movies at least 20 times. So I will be able essentially to use user fix effect and do even something better, I would say. So this is a snapshot of the main page of movielens.org. So you can choose different movies, and then once you select a movie, you can read a very short synopsis, and you can rate the movie. Now, we implement this dataset with information about the AMPAS Academy Awards, better known as Oscars, okay? And I restrict my attention on the so-called Big Five: Best Pictures, Best Director, Best Actress, Actor, and Screenplay, plus three other more specific awards. So each year, and for each category, a group of movies is nominated in mid-January, February. Usually we are talking about 5 movies. And then roughly 1 month after, one movie is awarded for each category. So now, from Wikipedia, I extracted the information about the nominated and awarded movies and the nomination and award date. So almost all movies are matched. So now for each rating Rij for movie I by user J, displayed, let's say, at time t, I can label whether the movie has ever been nominated or not, and whether the ratings is displayed before or after nomination. Now, for nominated movies, this TIT is straightforward to compute since I have the nomination dates. But this is more difficult for not nominated movies. So in these cases, I look at the date of the first rating, and then I assign a date of reference for nomination as the closest nomination after the first rating. Moreover, I discard classics, so I consider only movies in which the first rating is displayed in the first 2 years after the year of production. Okay? So now the conceptual framework that I want to use to have clear when I can or cannot identify disappointment by studying ratings of different movies over time. Okay, so here I assume each movie and user be defined by m+1 parameters. Okay, so for movie I, let's say a movie I is defined by theta I, the quality of the movie, and mu I, that is its position in a feature space. So you may think that a movie is more comedy, meaning of genres, right? More comedies, less drama, and so on and so forth. Similarly, users are defined by BJ, so how much they like to go to the cinema, and pi j, that is the user's position in the feature space. Again, you may think about how much a user likes or dislikes a specific genre. Okay, now the payoffs. So the expected utility of user J before watching movie I is equal to the expected quality of the movie. She did not watch it yet, right? Plus BJ, how much he or she likes to go to the cinema, minus, let's say, a met value, the difference, the distance, let's say, between the user and the movie in the feature space. So I denote with alpha ij the difference between these last two elements. So we have that the expected utility is equal to the expected quality plus alpha ij. Okay, now the ex post. So after watching the movie, user J observes the quality of the movie, and her ex post utility is now theta I plus alpha ij plus a gain loss utility factor that I take from Kozgecki and Rabin. So here we have a gamma, let's say, multiplying the difference between the actual quality and the expected one. So it's quite straightforward to observe that with a positive gamma, we can capture disappointment. Okay, now the timing. So a movie is, say, generated, produced, and with it, a group of potential users. And a signal, say, for example, nominations, appears, and a group of potential users becomes aware of the movie, okay? And they form expectations about movie quality, depending on the signal, and choose to watch the movie or not. So finally, after watching the movie, if the users decides to watch the movie, users report their ex post utility in the ratings. So here, essentially, in this framework, signals change the profile of aware users and users that are going to watch the movie, but also affect their expectations about movie quality. So by studying ratings over time, we will capture disappointment together with user selections. Yet we can do better, right? In particular, by studying the difference of ratings reported by the same users sharing similar characteristics, like, for example, the same genre, right? So we can denote the difference in ratings posted by same user J, right, about movie I and H, this delta J IH. So this difference will be equal to the difference in quality, the difference in terms of distance, right, the selection, and the difference in terms of expectations. Obviously, if we look at movies that are very similar, then of course the selection will be removed. Okay, now, if users then rate two movies, I and H, but only movie I receives a nomination, then by studying the difference between these two movies before and after the nomination, we may disentangle disappointment from selection, provided that, okay, we do a good job in selecting similar movies. So now, in the next slides, I will try to replicate this theoretical approach, first looking at ratings for nominated and not nominated movies around the nomination, and then I will try to isolate disappointment following the theoretical procedures that I explained in the previous slide. Okay, so here I want to start by looking at the variations in ratings for nominated movies around nominations. So to do so, I use an event study. So I regress the ratings only for nominated movies over a full set of dummy variables for each group of 5 days before and after the nomination. And in this graph, I plot the coefficients delta tau. And we can observe, well, two things, right? That ratings for nominated movies were already slightly decreasing before the nomination, and then they decrease even further. As we know, right, this drop can be due to a combination of disappointment and selection. Moreover, the negative trend before is in line with the selection story, right? 60 days before the nomination is Christmas time, usually. So it may be that users who watch movies at that time, they are different relatively to those who watch the movie later. And indeed, this seems to be the case also for not nominated movies, as we can see here in this figure, right? So here I perform the same event study, but now looking only at not nominated movies. So here I have a negative trend, similar to the previous graph, but after nomination, the ratings do not show a further drop, but they stay constant. But then I could use, let's say, not nominated movies. Sorry, here I went wrong. I could use not nominated movies to partially control for the selection of users who watch movies at different times. And indeed, not nominated movies seems to be a good control group in terms of pre-trend, okay? And I repeat the event study with all movies, allowing for different trends for nominated and not nominated movies. And here I display the coefficient beta tau over time. And we see that there are no trends before, whereas only after we observe that the two dynamics are different. Okay, so we know, right, that this result is already removing a bit of selection. But as I've shown before, I can do better, right, using the characteristics of the dataset. So for each nominated movie I can look at users who rated movie I, okay, and consider that the not nominated movies watched by user say J. So here, right, I can look only at movie I, then consider all the other rated movies, right, but that they are not nominated. And for each user J, I can, look at the not nominated movies, and I can compute this delta JIH as before. Now, if I just look at this delta JIH over time, I will be able essentially only to remove the fixed component, this VJ, right? That I did, that I introduced in my theory, that is equivalent essentially to a user fixed effect. But of course, if I consider only not nominated movies, age, for example, sharing the same movie features, well, then I am even able to remove the selection bias related to the movie user matching. Okay, so how I do it? Well, I use two exploratory data analysis, k-mean and k-median algorithms. So essentially, what I'm doing, I'm already using the information about the genre, and then I cluster movies inside the same genre. How I do that? Well, imagine that for each user J, I can look at the proportion of rated movies belonging to a genre. So imagine that I really like animation movies and I only watch animation movie, but never horrors. Or I may be a person with more, diverse tastes. But then for each movie I can look at the average proportion of ratings using all PJG, right, of users. So it may be, right, that, say, Toy Story is an animation movie that is watched, say, only by those who watch almost only animations, or it may not be the case, also by those who watch adventure. And with this piece of information, I will essentially cluster inside the same genre different movies using k-mean and k-median clustering. Okay, but then what can I do, right? I can, study the variations of delta JIH before and after the nomination date for movie I, using what combination IH fixed effect and a group of time variant controls. So here there are the results. So in column 1, I do not use any clustering, and I also do not restrict on movies with the same genre. Then from column 2 to column 4, okay, I restrict to movies with the same genre and in the same clusters using the two different algorithms. And later, I also add other time variant controls. And the results are, again, very robust, and they show a significant drop in the ratings of nominated movies after nomination. And well, I would like to claim that with this, I can, I claim that this drop is due to disappointment and not selection. So I can also provide again a new event study showing a decrease in the number of this delta IH after nomination. But I would say that now I think I can conclude. So here I evaluated the impact of certifications on buyers' expectation and disappointment. And how I do it? Well, I estimate the impact of Academy Award nominations on movie reviews, trying to disentangle selection and disappointment. The short-run effect of disappointment indeed is quite strong, accounts for more than 5% of the premium, okay, experienced by nominated movies. Let me say that this specific framework is particularly useful because we do not have a significant change in prices, we do not have an ongoing effort, and I believe that this is the right framework to study this question. So let me conclude with Shakespeare. Of expectation failed, but most of where there were most it promised. Thanks a lot.